We are on 3E, set 3E, and we're going to do all the problems. Number 1, as a sideline, the drug study compared blood pressure for women having different number of children. Below are sketches of the histogram for women with 2 to 4 or 4 children. Which group has higher blood pressure? 2 or 4? 4. How can you tell? There's more area to the right of the one on 4 than the one with 2. Okay? Does having children cause the blood pressure of mothers to change? It might. Just wait. Someday you'll understand. Okay? But was this an observational study or an experiment? Observation. Could you run an experiment like this? What would you do? You go have 4 children, and we're going to measure your blood pressure. And you are only allowed to have 2. It's never going to happen. Okay? So, or could the change be due to some other factor? Now, it very well may be that having more kids causes your blood pressure to go up. What could be a different explanation? What's that? Oh, that's true. Maybe Megan's going to give her children away. Okay. What else might be going on? Age, right. Does it say they're only going to have 2 kids? No, but right now they only have 2, and women who only have 2 kids tend to be younger than women who have 4 kids, right? So it might just be age, that more of the women who have 2 kids are younger and more of the women who have 4 kids are older, and that's enough to throw the data to the right. Okay? And you could come up with a whole bunch of other explanations, but I think age would be the big confounding factor there. Okay, number 2, hypothetical. The sketches on the next page show results from 2 other studies of the pill. Now, again, they just made this up. For women 25 to 29, in one study, the pill adds about 10 millimeters to blood pressure. In the other, the pill adds about 10%. Which is which and why? Which one adds 10 millimeters? The left one. How do you know that? It just shifted to the right. See that? The shape didn't change. All it did was shifted to the right. And what happened on the right one? It got longer and shorter. Why did it get longer and shorter? Well, let's look at, why am I going to do this the hard way? This is the easy way. So if we look at this picture here, when we go up by a percentage, how do we, let's say I have $85. Get my groove on. How do I increase 10%? Times it by, we could times it by 0.1 and then add it back to the original, but the fast way to do it is multiply by 1.1, right? How would I go up 25%? Multiply by 1.25. You could multiply by 0.25 and then add it back to the original, but 1.25 will do the whole thing at once because it's 100% and 25%. How do we go down 25%? You multiply by 0.75, right? 70. You keep 75%. How do we go down 10%? 90. Times it by 0.9. So if I want to go up 10%, I multiply by 1.1. Okay? So if your blood pressure is 85 and you multiply by 1.1, that's going to give us So 85 times 1.1. Now we land at, we went from 85 to 93.5. But this person is at 170. And 170 times 1.1, I go from 170 to 187. What do you notice about those shifts? What's the difference between this shift and this shift? A lot, right? This person only went up 13.5 millimeters. No, sorry, 8.5. I can't do my math. This person went up 8.5 millimeters, and this person went up 17 millimeters. But wait, they both went 10%. Why is one bigger than the other? Because one of them started with more than the other, right? So a linear shift of 10 just takes everybody where they are and steps them over 10, and the shape doesn't change. But a percentage change is going to vary across the board. Those that are close to zero aren't going to move as far, and those who are away from zero are going to move further, which is why these two have exactly the same shape, and this one got shorter and longer. Does that make sense? And the area underneath this curve is still exactly the same as the area under that curve. But when you stretch it horizontally, it has to get shorter to encompass the same amount of area. Does everybody understand that? This idea is going to be shown over and over and over and over. There's a difference between a linear shift and a multiplication shift. Linear shifts don't stretch anything, but multiplication shifts will stretch it. All right. Next up. Oh, that's it. We're done.